So we spent a lot of time talking about how to count things. And remember, counting depends on if whether or not order matters, and it also depends on whether or not you are using repetition or not. So remember, we had this chart for the formulas for counting. So here, order, if order matters, you're talking about permutations. Order doesn't matter, you're talking about combinations. You have repetition allowed or repetition not allowed. So when order matters, repetition's allowed. The formula is n to the k. If you don't have repetition, it's pnk. Order doesn't matter, k plus n minus 1 choose k. And if repetition is not allowed, it's n choose k. So those were our formulas we had for counting. Now let's look at a few examples of counting problems. So how many ways are there to arrange the letters of the word teach? So here, this word teach has 5 letters in it, and none of them are repeated. So here, identify order matters and repetitions not allowed. So that means we're using this bottom formula here, where k is the same thing as n. So this would be p55, or another way to write it, it's just 5 factorial, or 120. So how does it work when we have a repeated letter? How many ways are there to arrange the letters of the word sufficient? So here we have repeated letters, which means we need to look at how many are repeated. So S occurs once, U occurs once, F occurs twice, I occurs twice, C once, E once, N once, and T once. So there's 10 letters. So when we have a repeated letter, it's n factorial divided by your repetition factorial. So 1 factorial, 1 factorial, 2 factorial, 2 factorial, 1 factorial, 1 factorial, 1 factorial, 1 factorial. Now 1 factorial is just 1, so you didn't need to write it. It's really just 10 factorial over 2 factorial, 2 factorial. So there would be the number of ways to count the arrangements of the letters in that word. Let's look at a different counting problem now. So let's say a grocery store sells 4 different kinds of muffins. Assume there are at least 10 muffins of each kind, how many different selections of 10 pastries are there? So here, order doesn't matter in the choices that I make. It's the same collection of 10 muffins, and repetition is allowed. I can choose multiple of the same type of muffin. So in that table, the formula you should be looking at is k plus n minus 1, choose k. And so here, n is our number of types of muffins. So n is 4, which means n minus 1 is 3. There are 3 bars. And then r is our number of selections. So there's 10. Remember, those are crosses. So then it's 10 plus 3, choose 10, or 13, choose 10. So remember, we did these star or bars and crosses problems, and when you're selecting different types of an object, that was a bars and a crosses problem. Let's look at one more counting problem, and it's going to have 2 parts. So let's say I'm going to form a committee of people. Is to be made up of 4 people from a group of 10 juniors and 10 seniors. And I want to know, part A, how many committees are possible if the committee must contain 2 seniors. Well, if 2 seniors are required to be on the committee, that means the other 2 people would have to be juniors. And so it's going to be 10 choose 2, 10 choose 2. So this is the number of way to select the juniors, the number of way to select the seniors, and use the multiplication rule where you multiply these together. Okay. What if I change now the question to say how many committees are possible if the committee must contain at least 1 senior? So what are the possibilities? If it has at least 1 senior, it could have 1 senior, 2 senior, or 3 senior. Sorry, we'll change this to at least 2 seniors. So what does at least 2 mean? It means it could contain 2, it could contain 3, or 4, all 4 people. So we already know how many ways there are where it contains 2 seniors. 10 choose 2 and 10 choose 2. How many ways are there where there's 3 seniors? Well, if there's 3 seniors, it would be 10 choose 1. You would choose 1 junior times 10 choose 3. You would choose 3 seniors. And then if they were all 4 seniors, well, then you're only choosing from the 10 seniors and you're choosing 4 of them. And so then you've got to use the addition rule and add all those up. Okay, so in the end, your answer would be the sum of all of these here. Okay, so don't forget to use your multiplication rule and your addition rule.